This video, we're going to talk about graphing tangent and cotangent graphs. The thing to know when it comes to tangent graph is that this piece that I just drew keeps repeating forever and ever. It gets closer and closer to this line, and it gets closer and closer to that line. At negative pi over 2 and pi over 2. And as always, it keeps repeating from left to right. Now, this whole distance is pi. So we're at a half for pi. We go another half for pi, and then another half for pi. The next period is going to end here. And it's going to go like this. And this just keeps repeating. So, and again, this is y equals tangent x. So it's one period starts at negative pi over 2 and it finishes at pi over 2. That's the standard tangent x graph. So if you're asked to graph y is equal to the tangent of x minus pi, well, a tangent graph starts whenever the angle is equal to half for pi. So if you add pi to both sides, on the left is friendly to the right plus pi, on the right side is friendlier to right 2 over 2, which is 1 pi. That way when I add, I have common denominators. The graph is going to start there. Excuse me. It finishes at a half pi. I apologize. It starts when the angle is negative a half pi. So you add pi, you add 2 over 2 pi, and you get that x is equal to a half pi. Okay, so the first thing you do is you graph the tan x graph. Goes like this. Oh, okay, I start at half for pi. I finish at 1.5 pi. What's in between a half and 1.5? 2 halves, or pi. Now, this distance is pi, that distance is pi. So, you go to the left about the same amount, and you find the y-axis. And there is one period of this graph. It starts at negative pi over 2. It finishes at positive pi over 2. If you were asked to graph y is equal to tangent of 2x minus pi, 2x minus pi, not a problem. It starts when the angle is equal to negative a half pi. Add pi to both sides. You get that 2x is equal to a half for pi. On the left side is friendly to divide by 2, but on the right side is friendlier to multiply by the reciprocal. X is equal to pi over 4. Okay, that's where we start. Where do we finish? We finish when the angle is equal to half pi. minus pi. This is equal to a half pi. So add pi to both sides, so you just get 2x. And the right side will add the pi as 2 pi over 2. So we get 3 pi over 2. On the left, it's friendliest to divide by 2. On the right, I multiply by the reciprocal. So I get 3 pi over 4. Okay? That's enough for me. It starts at pi over 4. It finishes at 3 pi over 4. And it goes like this. And there's my graph. Now, in between 1 pi over 4 and 3 pi over 4, in between 1 and 3 is 2. 2 pi over 4, which is also pi over 2. This distance is pi over 4. So I go about the same to the left of pi over 4, and of course I find 0, which is the y-axis. Now, what if you were asked to graph 3 tangent x? Well, we know tangent x goes from negative pi over 2 to pi over 2. And this here is tangent x, where maybe the scale is 1, 2, 3, 4, etc. -1, -2, -3, -4, etc. That's for tan x. For 3 tan x, you get 3 times 1, which is 3, 3 times 2, which is 6. That is, the y's are just 3 times higher. Multiply this by 3, get -3. Multiply by 3, get -6, -9, -12. That is, the graph is the same. The graph is the same. I wouldn't even put any numbers on the axes. But if I did, they would be 3 times what they normally are. Okay, that's the graph for 3 tangent x. This scalar doesn't really do anything, except if it's negative. Tangent x goes between negative pi over 2 and pi over 2, and it goes like this. Gets closer and closer to the vertical asymptote. Okay, but we want negative that. That is, for this x value, tangent x says go up that amount. Well, negative tangent x says go down that amount. For this x, it says go up that amount. Well, negative tangent x says go down that amount. For this x, go way, way up here. Negative tangent x will say go down that amount. The negative of 0 is 0. So, at least to the right of the origin, the graph seems to go like this. To the left of the origin, for this x, tan x says go down that amount. Negative tan x, well, if you put a negative in front of a negative number, it becomes positive. It says go up that amount. For this x, it says go down that amount. Tan x does. Negative tan x says go up that amount. For this x value, Tangent x says go way down there. Negative tan x says go way up there. And as you can see, the graph goes this way. That is the graph of tangent x, negative tan x. And if I put a negative 3 in front, it's still this graph. It's still this graph. It's still that graph. Always label your x and your y-axis. Now, what would happen if I have tangent of x plus 1? Now, just so it doesn't, nobody can think that you mean tangent of x plus 1, how about we put the 1 in the front? Or at least put brackets around that. Well, the difference between tan x and tan x plus 1 is every point goes up 1. So, if this here is tangent x, well, every point goes up 1. This point here is now here. This point here is now here. This point is now here. This point is here. This point went up 1. This point went up 1. This point went up 1. And the graph suddenly looks like this. It's somewhat parallel. That is, any line, any vertical line should be a length of 1. They should all be exactly 1. They should all be between the two graphs. The solid one is y equals tan x plus 1, and the other one, the broken line one, is y equals tangent x. So, like always, the vertex is going to be at what makes that 0, comma, what that says. So, to graph it, what you can do is just go to that vertex, 0, 1, make believe that that's the new x-axis. The y-axis did not change, and the graph goes like this. It goes like that, where that is pi over 2, and this vertical asymptote is at negative pi over 2, and that's 1 right there. This y value is 1. Okay. Y is equal to cotangent x. Cotangent x goes between x equals 0 and x is equal to pi. And it goes like this. Of course, in the middle is pi over 2. That is the graph of y equal cotangent x. Starts at x equals 0, it finishes at pi. So, if you were asked to graph y is equal to cotangent of x minus pi, to start, you would let the angle equal 0, because it starts at 0. So x should equal pi. Of course, we all know that pi take away pi is 0. And it finishes when the angle is pi. Well, 2 pi minus pi is 0. Or, if you insist, you add pi to both sides, and you will get that it finishes at 2 pi. Okay, so it starts at pi, it finishes at 2 pi. So right in the middle, in between 1 and 2 is 1.5. It is going to go just like that. Now, this distance is pi. So I go the same distance to the left, and there's my y-axis. For the record, here is another period. But if the instructions just say to draw one period, doesn't matter which one you draw. The one that I have is just perfect. I let the angle equal 0. I found my start. I let the angle equal pi. I found my finish. And in between my start and my finish, I drew the cotangent graph. You need to know what a cotangent graph looks like, and you know that it starts at 0 and it finishes at pi. Now, if this here is the cotangent graph, and it goes from 0 to pi, x, y, then so this is y equal cotangent x, then y equals to negative cotangent x. Well, these are all positive. If you put a negative in front of it, they're going to be negative. Now this is pi over 2. You're going to be down here, and it's going to go all the way up to pi, the graph, from 0 to pi. Between pi over 2 and pi, it's negative. Cotangent x is negative. Well, if cotangent x is negative, and you put a negative in front of it, it's going to be positive. And what this is basically saying to us is that negative cotangent graph goes that way. That's negative cotangent x. So if you were asked to graph y is equal to negative 3 cotangent of x minus pi over 2. Well, the cotangent starts when that angle is 0. If you subtract two things and you get 0, that's because the two quantities were the same. And it finishes when the angle is equal to pi, which, by the way, is 2 pi over 2. So when you add pi over 2, you get that x is equal to 3 pi over 2. So we know where it starts. Starts at pi over 2. It finishes at 3 pi over 2. So we have 1 pi over 2, 3 pi over 2. What's in the middle of 1 and 3 is 2. 2 pi over 2, also known as pi. And it is a negative cosine graph. A negative cosine graph is the opposite of a cosine x graph. Oops. I apologize. This is, for right now, that's nothing. So here is where I start. And the cosine x graph, or the cosine of x minus pi over 2, looks like that. So we just draw it that way. That is what's in yellow. That is the graph y equals -3 cotangent of x minus pi over 2. The 3 does not matter. The negative does. Now, this distance is half for pi. Well, if you're at pi over 2 and you go to the left pi over 2, you will find the y-axis, because that's exactly where x is 0. And there's your graph. And if I said to add 2, all I would have done was go up 2, make believe my x-axis is here, and I would draw the same graph. I would draw the same graph except this up 2. And in theory, this distance should be 2, that should be 2, that would be 2. Looks like the lines are getting closer, but the vertical line is still fairly long. It's still about 2. 2, 2, 2. But nobody's going to measure that distance only because you're not going to draw y equals 2 cotangent of x minus pi over 2. You're going to draw it with the plus 2. Okay, there is your perfect graph. So, what I want to do now is to give you this table that you should know. Sine x, cosine x, tangent x, cosecant x, secant x. Now, actually, let me put it in a different order. Cosecant x, secant x, tangent x, and cotangent x. And along the top, we're going to put where it starts and where one period finishes. Where does one period start and where does that period end? Now, the good thing is, for the first 4, the answers are the same. They start at 0 and they finish at 2 pi. Now, when it comes to cotangent, it starts at negative pi over 2 and it finishes at pi over 2. Unfortunately, cotangent is not the same as tangent. Starts at 0, finishes at pi. The one thing that they do have in common is that the distance is pi. One period is pi. And for the record, the other 4, the periods are 2 pi. If you're going to learn it the way that I just presented it, you should know this table. If you don't know the table, it's going to be hard. So just one last example. Let it be a sine graph. Sine of x minus pi, or let's make it x plus pi, is going to start when the angle is 0. That means x is negative pi. It's going to finish when the angle, and that's the angle, equals 2 pi. Well, pi plus pi equals 2 pi, so x equals pi plus 3. That really doesn't do much. It starts at negative pi It finishes at pi, and it is a sine graph, which goes like this. And by the way, in between negative pi and pi is 0, so I have the y-axis. Now, this 3 comes into play. It's my scale. I'm going to call that 3 and that negative 3. There's no reason to call this 1 and say, oh, I should have gone up higher. No, absolutely not. There is your perfect graph. In between 0 and pi is half pi. In between 0 and negative pi is negative pi over 2. There is your perfect graph. And like always, the graph is what I draw first. Okay, get the graph right and plug in their information. If it would have been negative 3, all I would have done is drawn it upside down. So the blue is y equals to negative 3 sine of x plus pi, and their yellow is positive 3 sine of x plus pi. That completes this section on tangent and cotangent graphs.